Did you hear about the terrorist attack in Manchester, England?
I heard about it. They didn't have any death tolls or anything. What did it end
Yeah.
up being?
So there were two explosions. It was at an Ariana Grande concert.
Yeah.
And they're saying at least 20 dead and 50 injured.
Oh, okay.
Is what they're saying.
Yeah, last I heard it had there was panic and they didn't know how many people were injured or killed.
Right.
That's not too terrible bad, 20 dead, given there were 20,000 people at that concert.
Exactly. Right.
Wow.
I mean, compared to like the Brussels attack or,
well, I mean, these terrorists, they're not really very good. If you think about it, there's 20,000 people there and they only managed to kill 20 of them.
Right. I'd consider that a failure if I was on their side.
But if you go over every single terrorist attack, we got guys that are dying without killing anybody. They're suicide diers. They don't kill anybody. I mean, they're very incompetent. That's what I'm trying to say.
Stupid. Just stupid.
It wouldn't take much to kill a whole lot of people.
No.
Especially if you're willing to die. And
right.
the fact that they pull off an attack like that and they only kill 20 people, wow, that's amazing. When I asked you the question, I was expecting 200, maybe more.
Oh yeah, 200 plus, right?
Maybe it'll end up there. I don't know, but
you never know.
It kind of amazes me how few people actually are killed in these things.
Exactly. Seriously.
Except for 9/11, of course, 3,000 people died there, but
gosh,
everything since then has been relatively mild in terms of death.
Right. There are actually people out there that believe 9/11 never happened. I mean, how dumb do you have to be to believe that?
Alex Jones dumb. That's how dumb you have to be.
Right.
Alex Jones dumb. Donald Trump dumb. Man.
Yep. Exactly.
Trump dumb. I like that sound for that. Trump dumb.
Trump dumb.
Trump dumb.
It kind of fits, right?
Trump dumb. Yeah. That's an adjective on how dumb somebody is. They're Trump dumb.
Trump dumb. That's a good quote.
Like God. TrumpDumb.com. I'll bet that nobody has that domain name.
I don't think they do.
No.
I don't believe so.
Spell it D-U-M-B.
Right.
I'll bet you that's available. Trump dumb.
Trump dumb. I bet, yeah.
All right. Getting away from our task here, which is not a good idea, given that we only have 25 minutes left to get you to do as good as you can on this final.
For sure.
So, average rate of change. What's that mean? How do I get it?
So if you look at the table, so it's 0 is less than or equal to x, which is less than or equal to pi. So you just take the 0 and the pi. So would you just do y2 minus y1 over x2 minus x1?
Yeah, it's slope. That's what average rate of change is. It's slope. Only no y's. It's f. Excuse me. Hold on.
Yeah.
Let me just a second. I forgot I have to take a snapshot of this.
Okay.
It's f of the bigger number minus f of the little number all over b minus a. Notice what that is. That's the change in the y over the change in the x. That's slope. Rise over run.
Right.
Okay. But in this case, they want it between 0 and pi. So it's f of pi f of pi minus f of 0, the bigger number minus the littler number, all over pi minus 0. So, according to the table, what is f of pi?
2.
What's f of 0?
1. 2.
What is the average rate of change for this thing?
0 over pi.
0. Just
0.
0. If your numerator is 0, that's your answer.
Okay.
It does not matter what the denominator is.
Mm-hmm.
Okay? So the first one is 0.
Mm-hmm.
The second one, how would I set it up?
For 2, so you would do... Would it just be... let me see here. Minus 2.
F of what?
Oh, so f of pi over 2.
Right. The big number?
Yeah. Mm-hmm.
Minus f of the small number. So what goes in the
Right.
parentheses here?
2.
What's the small number? That's the small number.
0.
That's the big number. That's the small number. So 0 goes there.
Oh, okay.
All
My
over.
bad. I was looking at f of x, yeah. I got
all
you.
over pi over 2 minus 0.
Mm-hmm.
In other words, that's the rise, that's the run.
Right.
Now, fill it in. What's f of pi over 2?
So you get pi over 2 over pi over 2.
Hold on.
Which is 1.
Fill it in term by term. What's f of pi over 2?
F of pi over 2 is just pi over 2. Right?
No.
Oh, no.
Read
No.
the table.
Yeah, it's minus 2. Minus 2.
Okay. So that's f of pi over 2. I'm subtracting f of 0. What's f of 0?
2.
And it's all over pi over 2 minus 0, which is pi over 2. So what's that simplify to?
Minus 4 over pi over 2, which is negative 8 pi over pi.
Negative 8 over pi, correct.
Yeah. Cool.
Perfect.
Sweet.
Okay, so let's do the third one.
Mm-hmm.
And I'm going to erase the bottom and erase that.
Okay.
What goes everywhere?
So for this one, it would be f of 3 pi over 4 minus f of pi over 4.
All over?
All over 0 minus 2.
Oh, it's all over the big number minus the little number.
All over pi over 4.
Well, let's list it out. There's the big number minus the little number.
Okay.
That's what average rate of change always is. It's f of b, the big number, minus f of a, the little number, all over the big number minus the little number.
Okay.
This is what you want to memorize. And then you can use it for no matter what problem.
Mm-hmm.
But it's not that hard to memorize because that's the rise and that's the run.
Mm-hmm.
So the thing you really want to memorize is that the average rate of change is the slope. So you just have to apply the slope formula. Now what's f of 3 pi over 4?
So f 3 pi over 0. So it'd be...
What's f of pi over 4?
So it'd be 0 minus 0.
That's all I need to know. The answer is 0.
Yep.
I don't care what the bottom is.
No, because anything over 0.
Yeah, the bottom ends up being pi over 2, but as long as the numerator is 0, the answer is 0.
Uh-huh.
All right. Let's not spend our whole time doing average rate of change.
No, we're good.
Well, I don't know. You tell me. What we could. We can certainly. We'll do whatever you need me to do.
Okay, let's do just... Yeah, let's do just one of the...
We'll do D.
One of those. Yeah, let's do that.
So, remember what our formula is. What is it?
y2 minus y1 over x2 minus x1.
Yeah, okay.
Or f of...
That's all right. I don't mind using that terminology.
Okay.
So it's y of the big number minus y of the little number
Yeah.
all over the big number minus the little number.
Yep.
Now, what's y? Well, tell me what to fill in here.
Oh, whoa, what
What's
just happened?
y of b? How do I write that?
So would you just do pi over 2?
Well, let's write it as y of pi over 2.
Yeah.
And then we'll figure out what y of pi over 2 is. Minus what?
Minus y of 0.
Yeah. Notice why f of x notation is better than y notation.
Mm-hmm.
Because you don't have this problem. I really can't do this with y notation. This doesn't really make sense, y of b.
Mm-hmm.
But if I have f of x notation, I can do it. That makes perfect sense.
Yeah.
When I'm only defining things as y, then it's hard to say y evaluated at b.
Mm-hmm.
In other words, we can do it, and it's fine as long as you understand what I'm doing. And since they gave us the equation as a y equation, it's not terrible to do it this way.
Mm-hmm.
What's y of pi over 2?
So 2 cosine of x, or how would we?
2 cosine of pi over 2. In other words, if I'm going to use this notation, then I want to know what I do. I take whatever's in the parentheses and I plug it in for x.
Mm-hmm.
So what is 2 cosine of pi over 2? It's cosine of pi over 2.
Plug it into the calculator, right?
This is a non-calculator problem.
Is it? I guess it is.
You should know what
the 2's cancel out. Yeah, so the 2's...
They don't cancel out.
Oh, they don't?
This is the argument for the cosine trig function. That's just a multiplier of whatever that argument is, or whatever cosine of pi over 2 is. Okay?
Would it be 2 pi over cosine 2 pi over 4?
No, you cannot combine those 2's.
No.
No, let's look at the cosine curve.
Start maximum, go to, yeah.
What's the cosine of pi over 2?
Pi over...
Reading it off my graph.
Would just be pi over...
Okay, there's pi over 2. What's the y value right there?
0.
That's what it is.
Yeah. So it's just 0.
It's 0. Okay, so that is 0. Now what is y of 0? In other words, if I plug in 0 for x, what is y?
If you plug in what?
0 for x.
0.
That's what this means.
Right.
If I'm going to use y notation, then I need to know what y of 0 means. It means you plug in 0 for x. What's the cosine of 0?
Just 0.
Look at the curve. What's the cosine of 0?
1.
Now what's 2 times that?
2.
Okay. So this becomes 0 minus 2 is my numerator.
Okay.
All over pi over 2.
That's your answer.
Well,
Actually, no, you can simplify
that, so that becomes minus 4 over pi.
Yep.
So that's my answer.
Makes sense.
In other words, there really was no different in this problem than the previous problems. Other than the previous problems, I had to use this table to figure out what f of one of these numbers was.
Mm-hmm.
Whereas in this problem, they give you the function, y equals 2 cosine of x.
Yeah.
So if I have to figure out what y of the big number is, it's y equals 2 cosine of pi over 2. That's the big number. If
Yep.
I was doing E, it would be y equal 2 cosine of 3 pi over 2 minus 2 cosine of pi over 2, all divided by 3 pi over 2 minus pi over 2.
Okay.
So all of these do exactly the same thing. What
Mhm.
you have to remember is it is f of b,
Uh-huh.
the big number, minus f of a, the little number, over b minus a. And when I say the big number, there's the big number, there's the little number. There's the
Mhm.
big number, there's the little number. There's the big number, there's the little number.
Okay.
And our problem here, D, that's the big number, that's the little number.
Okay.
That's straightforward. It's rise over run.
Uh-huh.
All right.
Cool. Okay.
Now, let's go down and look at what next.
Let's do let's do 11. I think I know how to do these.
Okay. Yeah, let's just make sure you do.
Let's just make sure I'm doing them right. Yeah.
Find two angles, one positive and one negative, that are coterminal. What's coterminal mean?
Find the greatest like factor of the number, or no?
Coterminal. If I have a 30-degree angle, well then a coterminal angle is that plus 360.
Gotcha. So you use plus 360 and then minus 360.
Or
Right.
you can just keep taking more 360s. That's also coterminal with 30.
Right.
So what coterminal means is it's a multiple of 360.
Okay.
Okay? Now, you can go either direction. So
Uh-huh.
what's the positive one for 190?
550
What's the negative one for 190?
minus 170.
Now in radians, I'm not going to add 360. I'm going to add 2 pi or subtract 2 pi.
Yep.
So add 2 pi, what do you get?
Over 1. So the common denominator would be 9.
Okay.
And then yeah, so we would just multiply that by 9. So it'd be 7 pi over 9 plus 18.
Good. That's 25 pi over 9.
Yep. And then you can
So
simplify.
that's a positive angle.
Yep.
Now, how do I get the negative angle?
Minus.
Minus.
Yep.
In other words, we're doing exactly the same thing as we did with the previous one, only we were in degrees. This time we're going to leave it in radians from the get-go.
Uh-huh.
What's that answer?
Negative 10 pi over 9.
Let's find a common denominator.
Yeah. Minus 18 pi over 9.
What's that answer?
11 pi over 9. Minus 11 pi over 9, my bad.
Yeah. And finally, the third one. Let's do C, minus 95. What are we going to do to get the positive one?
At 360.
What are we going to do to get the negative one?
Minus 360.
On D, what are we going to do to get the positive one?
Add 2 pi and then subtract 2 pi.
Right. Okay, let's go on.
Okay.
You know how to do these.
Yeah.
These are pretty easy. When you're solving right triangles, it's all you have to do is figure out the trig function that's involved.
Yep.
There's no law of sines. There's no law of cosines. It's a right triangle. You never use the law of sines and cosines on right triangles. You only use them on non-right triangles.
Yeah.
Okay. Now, this tells me that B is 5 and C is 8.
Yep. So you could just use the, oh, what's it called?
Okay, they want you to solve everything. In other words, we need to solve for side A and we need to solve for both of these angles. So,
Okay.
how do you solve for side A?
You do a squared plus 5 squared is equal to 8 squared.
Not quite. It's 8 squared plus 5 squared equals A squared.
Well, isn't C the
That's the hypotenuse.
hypotenuse?
No, not in this case. Not the way I labeled it, it's not. I mean, you can label a triangle however you want,
Mm-hmm.
but the hypotenuse is what you're solving for here.
Okay.
And they did label it ABC, so I want to go clockwise, ABC.
Okay.
Now, they didn't really specify. In other words, is this the same as this? ACB. That's still the right angle.
Mm-hmm.
E would be 8. B would be 5. Same problem, right?
Right.
In fact, exactly the same problem. Angle C is opposite 8. Angle B is opposite 5 in either picture.
Mm-hmm.
Okay, so let's go back and use only one. So what is A? Solve for A.
Yeah, so it would be 64 plus 25 is equal to a squared.
So A is the square root of 89.
Yep.
So let's label it that way.
Okay.
I don't think that simplifies.
I don't think so.
Now, we still have to figure out angle B and angle C. We know angle A is 90 because it's a right triangle.
Uh-huh.
What trig functions, or how can we figure out these angles, B and C?
Use like cosine, sine, and tangent.
Pick one.
Let's do cosine.
Give me the equation.
So wait, let's see. So it'd be adjacent, so it'd be 8
Hold on.
cosine.
Always
So,
start your equations with the trig function and the angle.
okay, so
And
it'd be
figure out what it is. So which angle are we doing? B or
C.
C? C?
Yeah.
So what's the cosine of C equal to?
5 over root 89.
And then you can solve for C by doing what?
C is equal to would it just be
You take,
cosine?
here's the thing, Dylan. You take trig functions of angles to get ratios.
Right.
You take inverse trig functions of ratios to get angles.
Mm-hmm.
We're trying to solve for an angle here, C.
Yeah.
So it's got to be an inverse cosine of that number.
Oh, okay. Cosecant then, right?
Not cosecant,
Or not the inverse.
inverse cosine.
Okay.
Again, we take trig functions of angles to get ratios. We take inverse trig functions of that ratio in order to solve for the angle.
Okay.
So in your calculator, put in inverse cosine of 5 divided by root 89.
Okay.
What do you get?
I don't have my calculator on me. Can we go get it real fast?
No, we can only have 4 minutes.
Okay. I could do it in the calculator. Like, I know how to plug it in.
That? Okay. Let's say it comes up to be 41 degrees.
Okay.
Now, how do you get B?
Angle
B. The last thing to solve for. We've got everything else.
So we got 90 plus 41, which is 131. So we just do 180 minus 131.
Better to know that these two angles are complementary. You don't need to do 180. These add to 90.
Oh, okay.
So it has to be 49. In other words, the answer is 90 minus 41.
Okay.
You don't need to go all the way up to 180.
Okay.
Just know that the two small angles of a right triangle are complementary. They always
Okay.
add to 90.
Cool.
And now we've solved it. So we had to use a number of techniques to solve it. We had to use the Pythagorean theorem.
Yep.
We had to use one trig function at least. We didn't necessarily have to use cosine. I could have used sine. Could have used tangent. I could have said the tangent of C is 8 over 5. And then I would have taken the inverse tangent of 8 over 5. I would have still gotten the same number, 41 degrees. But I could have used any trig function.
Okay.
Because I know all three sides. So any of the 6 trig functions are going to work.
Okay.
Okay. All right. I guess that's a good place to stop as any, huh?
Yeah, that one's below it really easy.
Tomorrow?
No, it's not till Wednesday.
Okay.
Yeah. So, do you want to do a session tomorrow?
I'm fine doing one tomorrow. Well, let me, before I say that, let me look at my calendar because I think I'm actually booked pretty solid.
No, you're good.
I'm booked solid from 2:30 to 9.
Oh, geez. Okay. No, then no worries. Then we're good.
You have school tomorrow morning?
Yep.
Okay.
Yeah, unfortunately.
All right.
Okay.
Well, Dylan, good luck. I think you're in pretty good shape. I think you get this stuff pretty good.
I get it. I think I get it. So.
You know how to convert degrees to radians?
Yep.
And radians
you do pi over 180 times that, and then
radians to degrees.
180 over pi.
You got it.
Yep. Cool.
All right, Dylan.
All right.
Good luck. Are you playing baseball this summer in one of those
leagues?
Thank you.
I am. Yeah, I made the varsity team for Chaos.
Oh.
So we're going to be, we have 50 plus games in just probably 2 months. And then we go to Cincinnati, Indianapolis, and then Oklahoma.
50 games, that's a lot. I was watching the Rockies game today. They were saying one of the problems with players is that they don't get to play. They said that in one of these leagues they only played 16 games.
Really?
Like a high school maybe? I don't know. Do you only play like 16 games during a high school season?
Yep. I think Drew Goodman was saying that. I played. Yeah. You know Drew Goodman? Yeah, they're like Rocky sports announcer. I played on his son's team over last fall.
I remember you telling me that. Yeah.
Yeah.
He has mentioned that his son plays. And
oh, has he? Cool.
Yeah, he has. I remember him saying that. Yeah, they're always talking up local Colorado connections.
That's cool. I like how they do that.
He's good too. He's won lots of awards. He's one of the best announcers in baseball, as far as I'm concerned.
He is. Yeah. His son's really cool too. He goes to Arapahoe. Oh. He's a really good catcher. Really good catcher.
We were talking about a couple of Colorado high school players that have potential in the big leagues. I can't remember the names they were banding about, but
was Jack Winkler one of them?
I don't remember that one. I seem to remember a Joel Osborne or something, but...
Joel, okay. No, Casey Opitz?
No, I can't. I don't know that it was Joel Osborne. That's just the name that's coming to my mind, as they said. But
okay.
There's apparently a Colorado player or two who is draftable.
They're like 2 or 3 from Heritage, and I was telling you that.
It's pretty unusual. It's pretty hard for somebody from Colorado to make it into the pros.
It really is.
Yeah.
Right.
Look at how many Coloradoans have made it into the pros. There's a handful. That's about it.
Yeah, they're not many. Not many at all.
One pitcher for Colorado came from Colorado. Freeland? Yeah.
Kyle Freeland, I think.
I don't know what his first name is, but he's a rookie pitcher from Colorado.
And I think he throws really hard too, I think.
Well, they all do.
Yep. All the Colorado pitchers do now.
the starting velocity, the average velocity of starting pitchers. Guess who leads baseball? Colorado.
Colorado, yep. They have
Colorado.
the highest.
At 94 point something miles per hour. That's their
Consistently,
average. That's their average fastball for their starters. And
that's impressive.
That leads baseball. That's better than the Mets or Washington or the Cubs or any of those teams.
Right. And not only that, the Rockies have the best record in the National League right now.
Fantastic this year.
If they keep on this pace that they're going right now, they're on the road to a 108 game winning season.
Well, I just want to see them make the playoffs again. That was exciting when they were in the playoffs. So.
Oh yeah. If they keep playing like this.
Playoffs, yeah. Well, they got it all. I told a friend the other day they're a 5-tool team. They got great. They got good starting pitching. Good.
Got unbelievable players. Nolan Arenado, Cargo,
and great depth. They have unbelievable depth. They keep losing guys, starters, to injury, and man, they fill in with somebody that's just as good every time almost.
Oh yeah, Trevor Story's out with I forgot what it was.
Two guys that are playing shortstop that are
Alexi Amarisa and then Pat Ventura, I think, is the other one.
Vallejo.
Pat Vallejo, thank you.
Pat Vallejo, yeah. He's good, too.
He's out of, UCLA. He went to UCLA for college.
So, the Rockies are deep. Man, in fact, when everybody gets healthy, they're going to have a hard time finding playing time for...
oh, right. Gosh, I know.
What's the guy they picked up from Washington? Ian Desmond.
Ian Desmond. And then they picked up the catcher from the Phillies, Ryan Hannigan.
Right, he's good, but David Dahl is coming off injury, so they're going to have all kinds of guys healthy here, and no spot to put them.
Right.
That's
David Dahl has unbelievable power from the left side.
I love him. I love the way he swings.
I love his swing. It's so natural. Like it's just right.
He swings like a buggy whip.
He does.
That's what he said, and he does. Yeah, he's got a little whip. A little whip.
That's how he, that's how he gets the bats swinging around there like 109 miles an hour.
Buggy whip. Yeah.
Yeah. He can have it. He has an exit velo. He topped at like 116, which is just unbelievable power.
Yeah.
I mean, you can hit a ball over 500 feet with that power.
I've missed him. I enjoyed watching him last year a lot.
Oh, yeah, for sure. But
yeah, no, that's exciting. They're going to be fun to watch. I'm going to get to watch longer this year than in any season in a long time. Usually I'm done by May.
Oh, same, yeah. Usually by this time they start going downhill.
By May, but not
not this year. No, this year they're just getting started. Yeah. So awesome.
All right. Well, Dylan, you have a good summer. If I don't talk to you until next year, and keep in mind, like I said, I told Justin that the three of us and his dad, if he wants,
ping pong,
get together and play some ping pong.
I'm down.
They have a table at their house, so we can meet over Justin's house. And
sure. And I could also, do you want me to send you our game schedule? Because we have a lot of games at Chatfield this summer.
Send that to me, because I'm going to have time this summer. Yeah, no, it's something a lot easier for me to do in the summer than it is in the spring.
For sure. I got you, yeah.
Send it to me, please.
Sure. Let's see here. Yeah, I could just, I'll look it up online and get back to you on that.
Yeah, you just send it to my email.
Sure. Okay. Yeah, you want to send it to your email?
Yeah. You've got that in your phone, so.
Sure. Definitely. Let's do it. Awesome.
Well, good luck on your test.
Yeah, thanks, Mr. Cowan. I appreciate it.
You're welcome. Talk to you later.
Sounds good. Thanks, Mr. Cowan. All right, bye-bye.